So systems of equations, does that sound familiar?
Kind of, yeah.
Yeah.
We did a little bit last year.
Yeah, and you did a little in geometry. You would have done quite a bit in Algebra 1. And I think once I show you one, you'll, since it's a systems plural, what's that make you think? More than one what? Systems of equations. So it's more than one equation. In our case, we're doing today equations of lines. So if I have more than one equation of a line, what would I probably want to figure out about two lines? What would you want to know if you've got two lines graphed? Where they intersect, that's the number one thing. When you solve a system of equations, you're finding where they intersect. So our whole goal throughout this whole thing is we're figuring out where two lines intersect. Question, do they always have to intersect?
No.
Okay, that was definite. So, no, they don't. Ooh, that was really bad. Obviously, one thing they can do is they can intersect. We can just have them cross somewhere. But what else can they do? They could be parallel lines, in which case they aren't going to intersect. And there's one other thing they can do. Well, perpendicular would be intersecting, wouldn't it?
Oh yeah, so parallel.
We got parallel.
Be the same line.
Bingo! They can be the same line. So it could turn out you've got one line, and then the other line is exactly the same line. They're one right over the top of the other.
Just like parabolas and stuff now?
Okay.
Going opposite ways?
Right now we're only doing linear. We will come back and do where things that curve intersect at a later date. That will come back in December. But right now we're only doing lines. So the solution is, of course, going to be the point where they intersect. In this case, if you have intersecting lines, how many solutions did you get? And hint, there's a table on the journal. This might pertain to it. So if the two lines intersect, how many solutions did we get?
One.
We have one solution. Okay. If they're parallel, how many solutions did you get?
0.
Yeah. Are they intersecting?
No.
Yeah. So you have 0 solutions. All right. Then the biggie. What if they turn out to be the same line? All right. Somebody trained you. Well, yes, there would be infinitely many solutions because it would be every point on that line would be a solution. So those are the 3 choices. When we're solving, we're going to hopefully most of the time get one intersection point. But we can have the other 2 situations happen as we're solving them. So now, have a really, really difficult, actually I think I got room on that screen. Let me go back. Really difficult question for you here. If I give you a system of equations, and I say to you, all right, you got 3x plus 7y equals negative 1, and 5x minus 4y equals 14. This, on the old math assessment, this one came up all the time. I want to know, is the point 2, negative 1 a solution? So how could I don't want to graph it out, I don't want to solve it. How can I, with just this much information, figure out if 2, negative 1 is a solution? Yeah. If you substitute those coordinates in for x and y, what should happen? It should equal. So yeah, it should, in the top one, if I substitute in 2 and negative 1, I better, when I simplify it, end up with an answer of negative 1. If I substitute it in the bottom one, I should end up with 14. So we're going to try it. If I substitute in 2, negative 1, I would just simply put, literally, 2 in for x, negative 1 in for y, and hope I get -1 in the end. So you're really just doing a check is all you're doing. So what will that get me? Yeah, 6 plus -7 is indeed -1, so that one works, it checks. Do I have to go to the trouble to check the second one? Yes, because it might work in one and not in the other, so yes, you must check the second one. And so if I check the second one, still putting in 2 for x and -1 for y, I will get 10 plus 4, and hey wow, 14 also checks, and so yes, it's a solution, or no, it's not? Yes, it's a solution. Woohoo! Okay, was that amazingly difficult? Blew your minds with that one. So, our goal over the course of this chapter, I'm teaching you 5 ways to solve a solution of a system of equations. And you would probably go, why would we need to know 5 ways? Well, some ways are good if you have nice, easy numbers. Other methods are better if you have, if your equations contain nasty fractions and decimals. You may not want to use some of the algebraic methods. Some are quicker than others. Some I've been teaching probably now for 20 years, but because they're easy to program a computer to do, some of these methods you learn now are because it's very easy to set up a computer to solve by that method. So we get a variety of choices. But I know you're going to have seen some of these before. The first method we're going to do, and I'm curious to see your response, I want to solve them by graphing. How? If I give you a system of equations, how do you solve it? By graphing. And I'm going to give you 2 equations here. We got y equals -5/3 x plus 11. That one's in a nice form if I want to graph. But what if I give you 6x plus 10y equals 13? Who wants to graph this by hand and solve it? Why would this be unfun by hand? If you graph it by hand on a coordinate in the boxes, where do you need that answer to fall at? If you're doing it on graph paper. Yeah, it has to be on the corner of a square, some nice little intersection point. What if it falls at some fractional answer? Are you going to be able to tell what it is on graph paper? No way. So I've never been one to teach this to solving these by hand graphing, because you have to graph letter perfect, and your answers have to be nice whole numbers, so they fall on the coordinates on the boxes. So how are we going to graph and solve it? Calculator, yes. We're going to do calculator. However, I probably should go back there a second. We might as well do this first. If I'm going to want to graph these on my calculator, are they in the proper form that I can enter them in my calculator to graph? Yeah, the bottom one, what do I need to do to it? Yeah, you need a slope-intercept form. You need it y equals. So we might as well rearrange the second one now. I need to get it solved for y, which means I'm doing what with 6x? Yeah, I'm going to subtract 6x. And then I need to divide by 10. Okay. In this case, we can leave it like that and do it as fractions. Or actually, since we're dividing by 10, we could simplify this one down to being easier to work with. Why? What's the advantage of dividing by 10? Can't you do decimals? Yeah. So you could just do it as -0.6x plus what? 1.3. So we wouldn't have to go to fractions. Now, most of the time you'll have to type it in as fractions. You won't get that lucky. I didn't realize that was accidental, but this one came out that way. Most of the time you will have to type the fractions in, but we can get by on this instance with typing decimals. Okay, so where should I go? Graph. I'm going to say let's do a new document, graph, No, don't save that. So I'm going to add a graph page. The advantage of adding a graph page, if you start a new graph page, is that you get your coordinates back, you know, so we're graphing from -10 to +10 on the x-axis. If you go use your scratch pad, it's going to be zoomed to wherever the last thing was you worked with. You can use your scratch pad. And if you ever need to get your any graph back to normal, and it's not, if you can, the fast way is to go to number 5, zoom standard. That goes back to the normal -10 to +10 graphing. So if yours is ever really wacky crazy, just go zoom standard and it'll take you back to normal coordinates. But in this case, we're already there. Okay, so where do you type the equation? On the bottom. And if that's not showing, like right now the f1x is showing, if it's not showing, how do you get there? Tab always brings you there. So in our case, tab, the first equation was, and I am going to have to type it as a fraction, it was -5/3. Where do you get the negative sign? Okay, that gets you the fraction. If you want the negative in front, anytime you want negatives, be sure you use the negative below your 3 key. Don't use the subtraction sign. It will yell at you. So the negative signs are really teeny tiny. And then, yes, control divide to get a fraction. So we needed 5/3. Last block they said, well, how do I get my x out to the side? How do I get my x out to the side? Yeah, hit your right arrow, get out to the side, then put your x on. It was -5/3 x plus 11. And what should I do? Enter. And this one's nice. It's visible on our screen.
Now, can you change colors and lines?
You can. Not going to waste time right now showing you how. But if you go out in front of the F1 and press enter, there's a place you can change colors and stuff. These are actually pre-programmed to make F1 blue, F2 is a different color, F3 is a different color. It's got them pre-programmed to be different colors already. So I want to go enter the second equation. How do I get back down there to do the second one? Yes. Tab. It'll automatically go to a blank line. So, and that second one was, since we went to decimal, it was going to be a -0.6x plus 1.3. And hit enter. You can see the two lines. You have to be able to see the intersection point. If you can't see the intersection point, you'll have to zoom out so you can see the intersection. It's crucial that the intersection is visible. Okay, do you guys like it that way, or do you want the intersection point move more to the middle? Okay, hold on a second. Wheels pop. So, once again, we can find the intersection right over here in the bottom corner. If you wanted it, you could zoom out so it's not quite so far to the edge, but it'll work fine where it is. You guys already know how to intersect. Where do we intersect? Menu. Analyze graph. Intersection, number 4. Okay, what did lower bound mean? Find a point to the left. I am way, way, way to the left, so I'm going to move over closer to the intersection point. And once I get close, okay, you need to hit enter to say, dude, start the left edge right here. Because then notice it changes to upper bound. So that means go find a point on the right side of the intersection. So I'm moving to the right. You guys will see gray. Why are you not going, dude? Gray has gone. It is over there. Okay. And hit enter again. And yeah, that's not an answer you're going to get by hand graphing. You're not going to figure out 9.09. Okay, some calculators have more decimals than others. I tried last block to figure out. I compared their calculator to mine. We all have the same settings. It's somewhere deep in some menu. It's been changed. As long as you can see 2 decimals, you're only asked to give your answers to 2 decimals. So if you're seeing 2 decimal places, that's good. I'll keep researching. I got to figure out where they buried this setting.
Mine has like 5.
Yeah, some people have more than others, and all the common places I know to look are all stuff the same. So I don't know where the difference is. Okay, but ta-da! You found the intersection point. Woo! Exciting. Okay, and that's 50 minutes.